This time on Scott's Adventures, we're going to go to JPL in Pasadena and go on a tour. Hello and welcome to Scott's Adventures. Today we have a really fun thing that we're going to do today. I'm sitting in the parking lot of JPL, also known as Jet Propulsion Laboratory. About the only thing I know about them right now is on the TV show Big Bang Theory. That's where all of the guys work, you know. In theory, that's where they work. And if you've seen some episodes where they are in their lab or eating lunch or something, that's supposed to be here at JPL and where they work. So I know that they're very smart people, a lot of doctors, a lot of scientists, really brilliant people making spacecrafts and rockets and stuff, jet propulsion, things that are propelled, jet propelled. And so that's about all I know about the whole facility. So we're going to go on the tour today, learn all about it, and it should be really fun.
It would be an indication that life arises wherever the conditions are right, which means we might live in a
planet.
It's an ocean planet. 70% of the Earth is covered by water, and that makes it unique in the solar system.
The key to this abundance of liquid water lies in the delicate chemistry of our protective atmosphere.
Earth's atmosphere is actually very special. It contains almost the perfect mix of...
We alone? We do not yet know the answers to those questions, but we do know that we are all intimately connected to the universe.
Mars Science Laboratory, mobile laboratory on Mars. Cassini-Huygens, mission to Saturn and Titan. Kepler, searching for Earth-like planets. Juno, study Jupiter's formation, evolution, and structure. Mars exploration rovers, robotic geologists on Mars. Mars Reconnaissance Orbiter, studying the history of water on Mars. This spacecraft is called SWOT, Surface Water and Ocean Topography. It will make the first global survey of Earth's surface water by using JPL-developed instrument technology, radar. SWOT will measure water heights over land and sea. The long boom that separates its two interferometer antennas will be 10 meters apart on the full-scale spacecraft. Radar pulses will be transmitted by one antenna and received by both for interferometry, creating two parallel swaths of data. SWOT's 120-kilometer wide swath will cover most of the globe with multiple repeat measurements every 21 days, providing vital information about our ever-changing world of water. Cassini is a joint venture between NASA, the European Space Agency, and the Italian Space Agency. Cassini began orbiting Saturn in June 2004, carrying 12 instruments. The main mission is an intensive study of Saturn's rings, its moons, and magnetosphere. Cassini released the Huygens probe towards Saturn's largest moon, Titan, and the probe successfully landed on the moon's surface in January 2005. Voyager. Launched in 1977, the twin Voyager spacecrafts provided new vistas of Jupiter, Saturn, Uranus, and Neptune. Over the course of 12 years, these robotic probes explored and imaged planetary atmospheres, moons, magnetic fields, and ring systems. Both probes now are headed out of our solar system. They have measured conditions in interplanetary space and helped determine the extent of the Sun's influence. The Voyagers will transmit data as long as our instruments and power supplies hold out. Europa Clipper, exploring Jupiter's icy moon Europa. It shows strong evidence of an ocean of liquid water beneath its icy crust. Beyond Earth, Europa is considered one of the most promising places where we might find currently habitable environments in our solar system.
I mentioned the big things so you know what they are. First off, if you stay where you're at, just turn around real quick, you'll notice there's a picture of the sun. It's referred to as being our star because people forget it's actually a star. It just happens to be the closest one, so we call it sun. But if you walk around the room this way, the room is set up in the order of the solar system. As you travel through each planet, you're going to see there's a marble like this one. If the sun was as big as the picture you see there, well, Mars is as small as this marble here. As you walk around, you'll see the other sizes of the planets. When you get to Jupiter, it's about the size of a beach ball, okay? Other things you can check out, all the different missions spent 3 years on the surface of Mars. It was part of a spacecraft called Surveyor. When you look at it, you'll notice there's dust, that's moon dust that's on there. Over here in the middle of the room are the two older rovers we sent to Mars. The very, very first rover to go to Mars is the little one there. It was part of a mission called Pathfinder. It went to Mars in 1997. That's the same size as the real thing. It looks just like it. That's just a model. The real thing is still sitting on Mars. It never came back, okay? This one right here is the Spirit and Opportunity rover. They went to Mars in 2004. There are two of them. They look the same, so we call this a composite. It's the same size as the real thing. It looks just like it. Strictly a model, though. The real things, they're still on Mars. They don't come back. You'll notice both of these are solar powered. You're going to notice other spacecraft will have something different. So
Here you see 3 generations of rovers. Mars rovers kept getting bigger and more capable over time. Sojourner in the middle is about the size of a footstool. Spirit and Opportunity left are about the size of a golf cart. Curiosity to the right is about the size of a sport utility vehicle. Mercury is the planet closest to the Sun. To our eyes, it appears grayish. It has no atmosphere, and the surface is scarred by craters made with meteorites and comets smashed into the planet. Some deep craters at the poles may contain deposits of water, ice hidden from the heat of the Sun. NASA's Mariner 10 was the first spacecraft to visit Mercury in 1974, and the first one to use gravity assist to travel between planets. Venus shows what happens when a heavy carbon dioxide atmosphere and thick clouds smother the surface of a volcanic world. The clouds absorb heat from the Sun and from the surface and prevent it from escaping. As a result, a runaway greenhouse suffocates the planet. Volcanic eruptions have built low-level mountains, pancake-shaped domes, and ancient rivers of lava. Venus has fewer craters than some of the other planets because smaller objects burn up in the atmosphere before they can hit the surface.
you notice on the right and left part, there's black canisters with little fins. We call those radioisotope thermal electric generators. You don't have to remember all the words. We just say RTG, the 3 letters, RTG. Wait, the little pebble hits your windshield, it can crack your windshield, right? Well, this thing is in space moving 50,000 miles an hour. If that little pebble hits it, it might as well be a bullet. It can rip right through it. So the wrapping you see is there to protect against those small particles we can't see that hit it. The black stuff is made out of Kevlar. If you're familiar, that's the same stuff they use for bulletproof vests here on Earth. The gold stuff, we call that Kapton. That's made mostly out of Mylar.
NASA launched this first space-based optical telescope to Earth orbit in 1990. Hubble has beamed hundreds of thousands of images back to Earth, shedding light on many of the great mysteries of astronomy. It was designed so that new instruments could be added and repairs could be made by the shuttle astronauts. This full-scale model of the Galileo spacecraft appears here as it looked when it orbited and studied Jupiter. The high-gain antenna was only partially open, which limited Galileo's ability to send high-speed streams of data. Despite this setback, Galileo made many discoveries. It conducted the first asteroid flyby and discovered the first asteroid moon. It was the first spacecraft to orbit Jupiter and launch the first probe into the planet's atmosphere. Sensors to study fields and particles were mounted on the spinning portion of the spacecraft, which spun about 3 revolutions per minute. 4 optical instruments were mounted on the stable, non-spinning portion. Magnetic tape recorder. Galileo carried a 4-track, 114 megabyte digital magnetic tape recorder to store its data before transmitting it back to Earth. Saturn's moons. Members of Saturn's flock of natural satellites range in size from tiny, frozen moonlets to large worlds with atmospheres and geologic activity. At least 20 are embedded in the rings. Many of them act like shepherds to keep ring particles in line. Several supply the rings with fresh material, others orbit beyond the rings. Of all Saturn's satellites, scientists are especially interested in Enceladus and Titan. The blue ice giant. Neptune is a near twin to Uranus. This is because its interior, like that of Uranus, is comprised primarily of ice and rock. For this reason, Neptune is often referred to as an ice giant. The planet's atmosphere is made of mostly hydrogen and helium. Traces of methane contribute to the planet's blue appearance. Pluto is both a dwarf planet and a member of the Kuiper Belt, a region of hundreds of thousands of icy bodies and perhaps 1 trillion or more comets. Pluto and its moons complete one trip around the Sun in 243 years. Its frigid world is about 2/3 the diameter of Earth's moon. It has a methane ice surface and a very thin atmosphere. Explorer 1 was the first satellite successfully launched by the United States in 1958. This satellite also made the first space science discovery, the radiation belts that surrounded Earth. The JPL laboratory planned, built, and helped launch Explorer 1. The work done for this mission set the stage for the creation of the National Aeronautics and Space Administration, or NASA. As we walked through the JPL campus, I remarked to our guide how it looked very much like a university. He said that's kind of by design. The way it works is that NASA contracts with Caltech to have JPL build the spacecraft. So they're contracting labor and also the brain power from Caltech to move a lot of the scientists over here to help out during projects. None of the spacecraft here are military. Everything here is pure research. They're trying to find out more information to further our understanding of science, and they're using public funds to do that. And that being the case, what they need to do is they have to disclose everything that's going on in this facility because they're using public money. And also, the public has a right to come in and audit or look and see what they're doing here and make sure that their money is being spent correctly.
You can turn it in, feel free to take pictures. High bay number 2 is a 70-foot by 70-foot by 70-foot square room. This one is a 100-foot wide room. So yeah, so big tall things we built next door, big white things we built here. So if you guys remember a Cassini, that big giant gold one at the beginning, the real thing is 3.5 stories tall. They built it next door. Very far right, the very last one, you can see it has the emblem for Perseverance. That's the rover you heard about that went to Mars 3 years ago. If you guys have been thinking about robots collecting samples on Mars, looking for lights, it's that one you see on the end over there on that. We prefer the room very cold than too hot because we don't want them dripping sweat on things, right? So normally it's very cold in the room. You'll notice the humidity is usually kind of high, about 40%. Right in there, you build lots of static electricity. And we don't want static electricity because if you've ever worked on electronics, the first thing they teach you is to ground yourself. Our bodies build static charges. If you start touching electronics, you can send a static charge through it, you can short it out. We don't want anyone shorting electronics out. So to protect against that, we try to keep the humidity high so we don't build static electricity. And you'll notice on high bay BOP, there's a black wire attached to the left wrist. And the wire loops around the neck, clipped to the jacket. Do you guys see that? That wire is called a static ground or a grounding strap. They will clip that to something grounded altitude balloon mission that we're hoping to launch in the next couple of years, right? And this is what we're working on. Now, if you look in the room, you'll notice this gondola right there. That's the bottom part that holds the actual instrument, which is the telescope. If you look to your left, here's the instrument on the left. That's the telescope they're working on. It's a sub-millimeter microwave telescope. And then if you look in the center of the room, you can notice there's the gondola. That's the square part, right? If you've ever seen a high altitude, like those hot air balloons, the little basket, right? That's the gondola. That's like the basket for this. the antenna would go in the middle of that. Okay, and then on the top here, you can see this part where the parachute, the balloon connects. That's what you see over there on the right. You guys see that on the right? Yeah. So that would go on top of the gondola. That's where the balloon would connect. Okay. Now, this is going to be launched from Antarctica to get it up in the atmosphere above that, so you can see that, and that's why they're doing this. Okay. All right. Now the other thing they're working on, if I can ask you guys to move down this way, this is the part where I was saying is about the size of the Rose Bowl, right? So you can see it over here. They don't have the other one in here anymore, so they moved it. So this one, I think this is a live shot. Yeah, this is a live shot of McMurdo Sound. So if you guys are familiar, that's our base in Antarctica that they use to do a lot of the scientific research and stuff. And it's going to be the location where we're going to launch this thing as well. So, why that's important is because sometimes people say, you guys are hiding stuff. You guys found aliens, you're hiding it. We couldn't by law. Even if we tried to, we couldn't, because we would have to release the data, right? So that's why he was just commenting how we're allowed to take pictures, because we are in a public facility considered the stuff we produce is public domain. That's
In 1985, the Space Flight Operations Center was designated a National Historic Landmark. This building possesses national significance in commemorating the history of the United States of America.
Hey folks, feel free to take your picture and then find a seat. Why don't you go ahead and find a seat? We'll give you a chance to take more pictures at the very end as well. Like the DSOC, Deep Space Operations Center. And like it says, that's what they do. They operate all the deep space missions for NASA from this room. This room has been running 24 hours a day, 7 days a week, 365 days a year since 1964. Every deep space robot NASA mission since 1964 has been conducted from this room, right? What that means, if it's a NASA mission, it's a robot, there's no people on it, and it went to deep space, meaning it went to the moon or somewhere further away, and that happened after 1964. All those missions have been run from this room, right? We've sent, received, controlled it from right here. All the cool pictures you see in your science books, that information came through this room, and that's why it's a National Historic Landmark. In its history, we've used this to communicate and control more than 100 different spacecraft. On any given day, we could use it to talk to over a dozen different spacecraft in space. See the chart with the 3 sections, and each section there's silhouettes of antennas. On the left, you can see there's a name of a city with a flag of a country. Do you guys see that? Those are the 3 locations where we put our giant antennas. Now, if you look in the center screen, you can see there's an animation of one of our antennas. But if you look here, this gives you a better idea of how big it is. Here's a silhouette of a 6-foot-tall person. Here's a silhouette of that big giant antenna. Right, so it gives you an idea of just how big the person is compared to the antenna, or the antenna compared to the person, right? From one side of the antenna to the other side of the antenna, it's 70 meters from edge to edge. That means it's wider than a football field, almost as long as a football field. You could almost play football in the middle without falling off the edges. That's how big it is. Okay, it covers 120 degrees. 120 times 3 makes 360. We get full coverage around the Earth. Okay, so that's how we can talk to anything, no matter where they are. One of our 3 stations is always pointing in a different direction in the sky, okay? Now, at each of the 3 stations, we have big and small antennas. Each silhouette you see there represents either a big or small antenna. I'm assuming you guys can tell the difference, right? So, if you see the antenna lit up, that means it's turned on. If it's gray, it's turned off. If you look at the ones that are turned on, you notice there's letters above them. The letters are the abbreviated names of spacecraft. For example, that very first row, it says JNO. Any guesses what that could be? Years. It starts in 1957 when we built the system. It runs all the way till 2021 when we made the display. This is the timeline you can see moving from 57 to 2021. The blue dot, as you notice, that's the Earth. The red dots are all the different missions. The gray lines are the orbits of the inner planets. When the mission starts, you will see it listed here. You'll see the red dot appear. When the mission ends, the red dot will disappear. You'll see the name here go gray. By the time this timeline makes it to the bottom here in 2021, you're going to see there's 40 dots flying all over the place, because I told you we have more than 40 missions, right? Right now, you'll notice there's a misconception in the public. People think in space things go in straight lines, because in movies like Star Trek or Star Wars, everything goes in straight lines. In reality, nothing in space goes in straight lines. Everything in space moves in curves, right? And that's a byproduct of gravity because gravity is pulling on you, so you always end up in a curve. So you'll notice nothing goes in straight lines. It's a misconception. One of the other things is in movies, they make it look like our spacecraft go from space and land right on the surface of the planet. If we did that, our spacecraft would burn up in the atmosphere. The reality is most of our spacecraft, when they land, they go around the planet, it's up and down. We're talking to it. We're basically sending and receiving right now. Now you might notice one of them is green, and if you've been watching that, you might notice the green one keeps moving from one to the other. The green one simply tells us which is on the center screen. So right now the one in green is, well, that's weird. It's supposed to be the center screen. Right below where it says the Charles Lotche Mission Control Center, there's a red thing with a bunch of red numbers. You guys see it? Yes. That is the clock we use to schedule everything in space. Before I mention that, anybody familiar with Greenwich Mean Time? You guys familiar with that? GMT is the international standard for all of the clocks. That's the one we usually use. We don't use that version because that refers to something on the Earth, Greenwich, England, right? Our version, we call it the Universal Time Coordinated, UTC, Universal Time Coordinated. But it's the same thing. It happens to be the same thing as the military standard. Are you guys familiar with the military clocks? You might know it as Zulu time, right? Military clocks, they go all the way to 24, and that's because they don't want to get confused between daytime and nighttime. In space, there's no daytime or nighttime, so we use the military standard, right? So after 12 o'clock lunchtime, use what time we're going to start, what time we're going to finish based on the UTC. So you see SC, that's your spacecraft. If you look at the very bottom, JNO, that's the Juno spacecraft I just told you about, that's a Jupiter. It tells you antenna, ANT, antenna 63. So you'll see that's the one that they're using over here to talk to it, the 63. And then you'll notice it starts day 347, 1900 hours. If you look at the clock, that means it just started talking to it 28 minutes ago, right? If you look to the right, it tells you it's going to finish day 348, 0200 hours. So it's going to talk to it for like almost 6 more hours. As you guys come up here, look on the very left, you'll notice there's a slideshow. Right now it has the actress,
47 years.
her name there. She was in...
This is a full-scale model of the Mars Perseverance rover. It was launched in 2020 and landed on Mars in 2021. Its mission is to seek out signs of ancient microbial life on Mars. The 6-wheel robotic explorer is searching for rocks that could preserve signs of ancient microbial life if it existed. Perseverance has a drill to collect core samples of rock and soil, then store them in sealed tubes for pickup by a future mission. Then they would be returned to Earth for detailed study. This rover is paving the way for future human explorers by testing technologies that may be used on future missions. These include technologies that produce oxygen from the Martian atmosphere, a crucial resource for human exploration, improving landing techniques and weather reports that could assist astronauts living and working on Mars someday.
If you remember, the ones in the museum all had solar panels on the top. Solar panels work, but they only work in the daytime. So with this one, we decided to leave off the solar panels. Instead, we gave it that RPG, the nuclear battery we talked about earlier. You'll see it in the rear end. It looks like a white barrel with little fins on it, right? By giving that power source, this can work in the day or the night, during the winter or the summer. The old ones only work in the daytime, right? So we hope to send this up in the next couple of years. This is the actual size, by the way. This would be on lander. It would land somewhere close to where the rover is. The rover would take all the samples it's collected for the last several years. It'll stick it into the capsule on the top. This would launch into space. The capsule would go into orbit around Mars. A second spacecraft would capture it, take it the rest of the way back to us here on Earth. We're hoping to do all of that sometime by the early 2030, right? So sometime within the next decade. Now, did you guys hear about the Mars helicopter? Hopefully you guys did. There's the helicopter. So you might know it by its nickname. They called it Ingenuity. That's how big it really was. That whole thing was folded up. We stuck it on the belly of the rover. When it landed on Mars, it lowered the helicopter, drove away. Helicopter stood up, started flying around, right? Now, it flew 72 times. Unfortunately, on the last flight, as it was coming down, the rotor blade hit the ground and it broke one of them. So after it landed, it couldn't fly anymore. So after that 70-second flight, they ended the mission. So officially, that part is over. This is done. They ended at the beginning of this year. But this is still running, okay? They're still collecting samples for us.
This display is called the Pulse. It reacts to live communications between more than 30 interplanetary spacecraft and the Deep Space Network. Uplinks to the spacecraft trigger streams of light upward. Downlinks back to Earth trigger lights downward. More activity in the light means more data transmitted. You can also see the name of the spacecraft it's communicating with scrolling through the center.